When we introduced the Riemann integral, we were interested in computing the area between the graph of a single function, f of x, and the x-axis. Now, we'll try to generalize this to more complicated regions in the plane. So suppose now we have two functions instead of one. So the two functions are f of x and g of x. And we'll assume that f of x is greater than or equal to g of x. So what this means is that the graph of f of x will lie above the graph of g of x. We want to come up with a formula to compute the area of the shaded region between the two curves. So we'll follow the same ideas as we did in the Riemann integral. Right, so we're going to imagine subdividing this interval into subintervals. So to make things simpler, we'll just imagine doing one of these subintervals. And so again, the idea is to draw an approximating rectangle. So in this case, the approximating rectangle will be different, but the ideas will still be the same. Right, so first, we mark off a point on the x-axis where this rectangle is. So let's call it x. So to find the area of this rectangle, we need to find the height and the width as before. Right, so the width of the rectangle will be dx. So the same as before. And now we have to compute the height of the rectangle. Right, so if you notice, the height of the rectangle is the distance between the two functions f of x and g of x. So it's slightly different than before. So now, to compute the distance between f of x and g of x, in this case, is going to be f of x minus g of x. So the height is f of x minus g of x. To get the area of the total region, we start with this single rectangle. So it's height times width. Right, so the height is f of x minus g of x. And the width is dx. And so now we have the single rectangle. And so to get the total area, we have to again sum over the entire interval. So the sum over the interval will be the integral from a to b. So in total, the integral from a to b of f of x minus g of x dx will compute the total area of the region between f of x and g of x. So the way to remember this formula is that the top curve, so the function representing the top curve, should come first, and the function representing the bottom curve should come second.